Let's continue our discussion of scientific notation in Scientific Notation Part 2. All right, for example, we're asked to write in scientific notation, and we have the number 5,600 times 10 to the negative 7th. Now, you might say, wait a minute, that number's already in scientific notation. That's not true, and the reason it's not true is because, remember, two things have to be true. The first number has to be a number between 1 and 10, which it isn't, and the second number has to be 10 to the something. So of course 10 to the something's okay, but we have to write this as a number between 1 and 10. So what we're going to do is we're going to, we're not going to be able to write that as a number between 1 and 10, but what we have to do is write this as a number between 1 and 10 multiplied by 10 to the something, okay? So for example, 5,600, if I take the decimal, which is right there, and I move it over here, I get 5.600, right? Now, of course, these are not the same. So what do I have to multiply this by so that what I have here is equivalent to that? Well, this decimal has to move which way? Well, to the right, 3 places, 1, 2, 3, to get back to that. And so this is times 10 to the, that's going to be positive third. Okay? So the point is that 5,600 is the same thing as 5.600 times 10 to the third. But then we still have this, right? We still have times 10 to the negative 7th. Let's write that out. Okay? So what I did is I simply acknowledged that 5,600 could be written as 5.600 times 10 to the third. And now that I've got that, now that I have 5.600, now I can say, wait, these have the same base, a base of 10, so I can add the exponents. So I get times 10 to the, let's see, 3 minus 7 is a negative 4. Okay? And this would be my answer. So now the number's in scientific notation because both criteria are satisfied. Okay, let's try another one similar in spirit to that. Okay, we're asked to multiply and then write the answer in scientific notation. So I have 4.2 times 10 to the negative third, and I'm multiplying that by 5.1 times 10 to the 8th. So what we're going to first do is multiply 4.2 and 5.1 together. And whenever you multiply two numbers together that have decimals, the way we do it is we temporarily forget about the decimals, and that would leave me with 42 times 51. And I just multiply those numbers together first, and I get, let's see, 2, 4, 0, 10, carry the 1, 21, right? Then I add those together, and I get 2, 4, I get 2142. Now, of course, then what you do is you say to yourself, how many decimal places did you ignore? Well, I ignored 1 here, and I ignored 1 decimal place there for a total of 2. So I come back to this number, and I move the decimal over 2 places to get 21.42. So 4.2 times 5.1 is 21.42. And then I multiply together the exponential expressions with the same base. So I'm going to get times 10 to the 5th. Now, is this in scientific notation? The answer would be no, because this is not a number between 1 and 10. So what I can do is express this number right here in scientific notation, and I get 2.142 times 10 to the 1st, right? And then times 10 to the 5th. Let's check that. If I multiply just this by 10 to the 1st, this decimal would move 1 place, so all of this right here is equal to 21.42. That is that. And then I still have 10 to the 5th. So what's the advantage of doing that? Well, now this right here is a number between 1 and 10, 2.142, and then times 10 to the, multiplying these together by adding the exponents, 10 to the 6th. And that would be my answer. Okay, let's try another one, but involving division. So we're asked to divide and write the answer in scientific notation. So once again, the first thing we're going to do is divide the parts of the problems involving the decimal. Now, because it's multiplication, I'm free to take 1.575 and divide that by 3.5. Now, the way we divide decimals is we take the divisor, and then we write the numerator, that is the dividend, under the division symbol. So 1.575. And what you do is you move the decimal in the divisor over to the right as many places as needs be, in this case just once, until it's been cleared. and then you move this the same number of places, so that would be once. So this decimal moved once because that one moved once. And then you perform the division with this decimal place. So 35 does not go into 15, so I have a 0 right here, but it does go into 157. It goes in 4 times, and then you multiply and you get, let's see, it's going to be 140. And then subtract. We have 17, bring down the 5, and that's going to be 5. Let's see, 25, yeah. So 175. Okay, so when I divide 1.575 by 3.5, I get 0.45. So that means that that divided by that is just 0.45. But then you still have what you get when you divide 10 to the negative 12th by 10 to the negative 5th. Now, because these have the same base, that is a common base of 10, you take the top exponent, negative 12, and subtract the bottom one to get the new exponent. So it'll be times 10 to, let's see, negative 12, take away negative 5. That's negative 12 plus 5, which is negative 7. And is that in scientific notation? Well, no, because again, this is not a number between 1 and 10. So I write 4.5, and it's going to be times 10 to the what? Well, this decimal has to move once to get back to 0.45. That is once to the left, though, right? So this decimal has to move to the left. So it's 10 to the negative first, and then you still have the times 10 to the negative 7th there. So finally, our final answer is 4.5 times 10 to the negative 8th. Okay, so that's how we handle scientific notation. Until next time.